Um, a very common question encountered in the USMLE step 1 is what is the relation of prevalence with positive predictive value and negative predictive value. Let's get to the crux of this question. So whenever you come across questions including sensitivity, specificity, NPV, PPV, the first thing to do is to make a box, because that makes life really easy. So this is the test, this is the disease, this is positive, this is negative, this is positive, this is negative. Now this is going to be true positive, this is going to be false what? False positive. This is going to be, why false positive? Because the test gives you positive, but it's a false positive. The test gives you negative, so it's a false negative, because it should have been a positive. So, and here's going to be true negative, because it's a negative and the test gives it negative. Now how do you find out specificity? So this is specificity, sensitivity, positive predictive value, negative predictive value from this particular box. This box makes life very easy for you, because now all you have to do is just slide your finger. Here you go for the positive predictive value, for specificity. Here you go for very sorry, I think I might have just rearranged this thing, so no problem. This is sensitivity and this is specificity. So let me go again. Here you go for sensitivity, here you go for specificity. This way you go for positive predictive value, this way you go for negative predictive value. Once you have this in mind, life is super smooth. Now let's say, for example, a population has an increased prevalence of HIV. So in that population, HIV is more. And they ask you what happens to the PPV and the NPV per se. Now, let's see what happens. So the understanding here is that when I say disease prevalence is more, it means the positive in this population is more. So this goes up, this goes up. And where do these people come from? They come from this negative. They have moved from negative to positive because they've become infected. That means the FP goes down and the FN goes down, because this whole value goes down. And the effect of this going down will be on both of them. And there you have your answer. Because if you talk about the positive predictive value, PPV from the way I told you to predict is going to be this one. So it's going to be TP upon TP plus FP. TP goes up, TP goes up, but FP goes down. So even if this value is neutered out, TP finally goes up, which means the positive predictive value goes up. And that is exactly the effect of increase in prevalence on PPV, which means the PPV is increased. Now let's see the effect on NPV, the negative predictive value. So when you talk about the negative predictive value, NPV by our formula is going to be, we go like this, right? So NPV is going to be Tn upon Tn plus Fn. The idea here is that Tn goes down. This value could be rectified because one goes down, one goes up. Overall Tn goes down. Now Tn actually, the true negative nearly goes to 0, so the NPV nearly goes to 0 as well. Anyway, NPV goes down, PPV goes up, and this is when the prevalence of the disease is high. And that wraps up your discussion on the correlation between prevalence and PPV and NPV.